Okay, when last we spoke, we had this picture of a neuron, linear equation of the inputs, and the idea that if the output was above a certain value, it would be a cat, and below a certain value, it wouldn't be a cat. So, the next important thing about neural networks is that they learn, that they are trained. Where did those weights come from? Did we kind of just say, well, I think horns are 0.7 important in a negative direction and eyes are 0.42 important in a positive direction? Well, we could have, but then after doing that, we probably want to fiddle with the numbers to get it to actually work right. And that's what training a neural network is. So the main idea is we're going to train this one neuron network by giving it a set of values, features, putting it through with whatever these weights are, putting it through the linear equation, putting it through the neuron, getting a decision. If the decision is right, we're happy. If the decision is wrong, we want to adjust the weights so that with these input values we get a different answer. Well, we're going to actually nudge the weights. So if the decision was wrong and we got an error, we'll go through and we'll say this horn here contributed in a negative direction, and the horn was pretty significant. We were pretty confident in it. So we probably want to increase this weight a bit so that the horn is contributing more towards negativity. And the eyes, similarly, we'll adjust this weight down a little bit. We had a lot of eyes. We got a wrong answer. We'll adjust the eyes weight down a little bit so maybe they pushed us into the wrong direction, like that. So it takes the error, looks at the values of these features and the weights, and nudges them in a direction. If a particular feature was 0, then it wasn't contributing to the wrong decision, so we don't change its weight. If a particular feature was large, it might have been contributing a lot to the wrong decision, or it might be contributing in the right direction, so we'll adjust its weight according to its value, its directions. So we can see how much each feature contributed to the wrong answer, and we'll take that error, that adjustment, we'll divide it down it's called the learning rate. We'll say maybe let's take 5% or something and nudge the weights by 5% in the direction that we want to go. And then we'll give it another picture of a cat or a non-cat and do the same thing and do that over and over. And we'll go back and we'll take the same data and we'll run the same data through many times, the same set of pictures maybe with the same right answers, and each time we nudge the weights a little bit until at some point it learns. At some point the weights start to converge on values because remember, we're juggling a lot of weights and a lot of input values all at the same time, and but by nudging them for each example, this example had a really strong picture of wings, so that's going to do a good job on adjusting the wings weight. And this example had hardly any wings, so the wings weight won't fix, So that's one of the reasons we're nudging them. And at some point it's trained and it gets through the test data, hopefully, without making any errors. And that's what training a neural network is all about. This process of learning, this is machine learning of a kind. This process of learning is by itself considered to be an intelligent behavior, which computers didn't used to be able to do. So looking at the picture and deciding whether or not it's a cat is an intelligent behavior that people now know how to do with algorithms. And training the algorithm. We didn't sit down and write a piece of code which had, if statements in it saying, if this, then that, oh, it's a cat. We sat down, we gave it this neural network thing, and we trained the neural network on some data. So learning to distinguish what's a cat is the other intelligent behavior that this neural network has emulated. So that's the basic idea behind what's a neuron and how neural networks can be trained. Ultimately, we're going to have what? We're going to have this network. So these purple, blue boxes here, each of them is going to be one neuron. So we could imagine that each feature, could feed each of these 5 neurons. So here we have 1, 2, 3, 4, 5, 9 different features. So this neuron could get input from all 9 features. This neuron could get input from all 9 features. Okay? So each of these neurons is making a linear function of all 9 features. So in some ways, each of these neurons is making a decision. And then we'll take their decisions and combine them in the same way. So it might be that this one neuron, thinking of our cats, is, it's concentrating on the eyes and the feet and things like that, so that all the different pictures that have 2 eyes and 4 feet, it's figured out 2 eyes and 4 feet go together as a kind of cluster of features which are important. And maybe this neuron looking at a couple of other features, maybe a few features which we haven't seen yet. Maybe looking at the color, maybe the whiskers. You notice we didn't have the whiskers. And then, so we get out of each neuron a kind of synthetic feature that was a combination of stuff from the inputs. And then we take all those and call those like our next set of features. They each have weights. They go into a final neuron, and the final neuron gives you the result, which will be either yes, it's a cat, or no, it's not a cat. That's the network part of neural networks. And the training works like I just said. The difference being now we have more weights to adjust. So we, gets a wrong answer. We got to adjust these weights, and there's, this neuron had some output. If it was 0, then we don't adjust this weight, but then we have to adjust the weights going into this neuron. Like that. And if you think about it, if we have 9 features here, and we have 5 neurons, then there's 45 weights. There's 45 weights going into, there's 9 weights going into the first neuron, 9 weights going into the second neuron, like that. So we end up with a lot of weights. But that's okay. We give it enough data, we can train them, keep nudging them each time, and eventually it works. All right? Okay, so that is the main notions behind neural networks and training them. Again, the link to this web page is on the the class Blackboard site.